Okay. So if we investigate 0.5 to the 0.1 is 0.933. 0.4 to the 0.01 is 0.99. And so on, at least until you see the what's up. I get 0.998. It feels like it's getting really close to 1. Do you agree? I feel it. All right, you could do the fourth one if you like. Okay, now, 0 to the 0, could it be 1? Well, yes, in that case it was, but let's investigate if we switched the two and the base went closer to 0 in an exponential way, and the exponent went to 0 in a linear way. So maybe 0.5, 0.4, 0.1 to the 0.5, like 316. 0.01 to the 0.4, 0.158. And smaller, 0.001 to the 0.3, 0.1258. Feels like it's getting smaller. Don't bail on me yet. 0.0001 to the 0.2. It starts to get bigger. Now that, you'll see, is actually pretty doggone kooky. This thing actually bounces back and forth. It does not, on the surface anyway, converge. That is to say, I'm not even sure what the limit is. It's doing a little oscillating thing. All right? That's why we would need the calculus, because the calculator only goes so far. The other ones, you could do that same kind of process, and if you feel like it's value added, I'll walk you through it. But the idea is you can investigate and see that depending on how the things get big and small, you actually could get very different outcomes. And so the point of all this is numerically it shows there's some gray area. It's indeterminate. You with me? Okay. In that respect, because we're pressed for time, I'm going to go to the nitty-gritty here. All right. Now, just like in the previous two, I want you to first, as your starting point, make sure it's indeterminate. The work we're about to do to find the answers to these is long and tedious, and you don't want to do it if you don't have to. So it is crucial that you correctly identify indeterminate forms or not. All right? So, tell you what I'd like to do. Actually, let's go here first. So these are the 7 indeterminate forms. Some of them you know by far already. Some of them you've been doing since set 91, but these 3 might require a little bit of study. Now, these then, if you were to get a limit from these forms, these are not indeterminate forms. For example, what's small positive divided by huge positive? Is that, I don't know. What is it? 0. What's huge number divided by small positive? Huge positive divided by small positive is huge positive. What about a tiny number to a big power? What if you took a 10 to the millionth power? What's a tenth of a tenth of a tenth of a tenth? 0. That's not, I don't know. That's 0. What about, geez Louise, huge number times huge number? That's not, I don't know. Okay, huge number plus huge number. Please don't even think about saying to infinity. That's ridiculous. It is not to infinity. What's infinity plus infinity? Infinity. Like love. Love is love, not too love. It's just a lot of love, all right? They're ideas. They're not numbers. They're not quantities. They're ideas. So that's infinity. And what's negative infinity minus infinity? Obviously negative to infinity, not negative to infinity. All right. Now then, the first thing you'll do when you get one of these problems is say, all right, first verify, first make sure it's indeterminate. So I think I'm going to jump a little bit. Would you go to the back, please? And for every one of those problems on the back, would you figure out which indeterminate form, is it an indeterminate form or not? Oops. Okay, let's see if we agree. On 2, do you agree that it's infinity to the 0? And that is indeterminate. Okay? 3, infinity to the 0 is indeterminate. indeterminate? Yes, it's right there. It's the same as that one. Sorry. 4. Did you get 1 to the infinity, which is indeterminate? 5, finally one that's not. I get infinity and top, or huge positives, divided by huge small positives. That's infinity. That is not indeterminate, right? Do you agree? Okay. This bad boy, it's 0 in the base, 0 in the exponent, 0 to the 0 is indeterminate. X goes to 0. This guy, it took me a little while, but I believe it is 0 to the 0, so that is indeterminate. Yay? Right? 8 is infinite to the 0. That is indeterminate. 9, approaching 0 to the infinite, small numbers to huge powers is not indeterminate. It is 0. And 10, I get 0 to the 0, that's indeterminate. And 11 is infinity to infinity. That is not indeterminate. Are we cool? All right, then. So we practiced making sure it's indeterminate. I think I'm going to do a little switching because, what the heck? This is not good. So I'm feeling I'm going to save this for the second. That's unfortunate. Why does not like this? It's no good. What's the problem? Why doesn't it like me? Okay, well then, anyway, I guess I'll go over here. Example 1, I think I'm going to switch example 1 with the first problem. So would you, under that example 1, would you scratch it and change it to the easier limit as x goes to 0? What was example 2? X to the 1 over x, is that right? On the back. X. Is that the first one on the back? To infinity. Okay, gotcha. Okay. That first example, oh, here we go. This one is a little messy, so it's kind of a bad first one. Let's instead do a nice clean one like x to the 1 over x. Are we cool? And we decided that is infinity to the 0, that's indeterminate. Now we've seen the numbers, I showed you, I reminded you which is indeterminate, which isn't. Now let's talk about how do we do these new ones, all right? Typically, when we have a problem in the exponent, how do we deal with that? What's the math way we deal with it? I have a problem in the exponent. Natural log. We take natural log to help us out, yeah? Now, another rule of math, even bigger rule of math, is you can't just go changing something all willy-nilly. You have to keep it balanced, yeah? Now, this doesn't really have two sides so much as it's just an expression. So I can't log both sides because there aren't both sides. There's just a side. So the only way I'm going to undo or balance the equation with natural log is if I also e it, or exponentiate. So if you get an exponential form, this first step you will typically bypass. But your idea is that you're going to e at natural log the expression. Now that's a net change of nothing because those are inverses, right? Now this is the part that first time through students tend to bristle at a little bit. Actually, I should bring this over here. All right. Now e though is a constant. So I'm going to just focus on the variable stuff. Now what that is to say is if I want to know what this equals, I really need to just know what this equals and then e it later, right? Another way of saying that is I need to focus on what does just the functional stuff go, and then I'll e that after. Now that's a limit, and it's a lot. It is just basically saying I want to focus on what the variable stuff does, and then the constant e is a constant, so the limit doesn't affect it. So I can take that e later. Are you tracking? All right, now that gets us rolling. E to the, that allows us to use our limit rule, our log rule. This is infinity, right? Not zero. So that, with the log rule, allows us to bring the exponent 1 over x down. And might as well write the x in the denominator, yeah? Now it starts to look like what we call. If the limit as x goes to infinity of natural log of x is infinity, and the limit as x goes to infinity of x is infinity, then by L'Hopital, this problem is equal to the ratio of the derivatives, which is 1 over x over 1. Now that can be evaluated. What is 1 over x approach as x goes to infinity? 0. And so our answer in this case is e to that limit 0. So our answer is 1. You follow? So if you took bigger and bigger bases to smaller and smaller powers, they would kind of knock each other out, and it would approach 1. All right, let's try a few variations on the theme. I'm going to change this one to the one that I was about to do. What was it? 0? What was the one on the front, please? X to the sine of x. Okay. We're still not quite ready for that, so let's go to this one, please. Go to example 3. Now, we said that was indeterminate a second ago, I believe, right?
Yes.
Okay. So, if I get an exponential indeterminate form, how do I get rolled? E and log. Okay. Now, I'm okay if you actually, this kind of goes teacher by teacher, but what the freaking happened? I'm okay if you went straight to this step, the E out front and the log inside step. I'm okay if you start with the E out front because it's always going to be the case that E will be. Is that right? Oh, okay. I take this one. All right. So here we go. I'm okay if you start this way. E to the and natural log of 1 plus x to the 1 over x. Now I prefer you show the natural log without bringing anything down first. I feel like that's not doing too much anyways. The limit as x goes to infinity of the log of 1 plus x over x. Wait. You got a fraction on feeling indeterminate form, so let's do some good quality L'Hopital. The limit as x goes to infinity of log of 1 plus x is infinity. And the limit as x goes to infinity of x is infinity. And so by L'Hopital, our problem changes into 1 over 1 plus x over 1. This one's a lot like the last one, I guess, sorry. Which is e to the 0, which is, okay? Now, just to prove to you that they're not all the same, would you do 4 on your own? And I assure you it will not be 1. What do you get? E to the 4, right? E to the 4. Okay. Okay. Worst case, and this is not a new worst case, but a worst case just like these is if you have to do it twice. So let's go that first one that I should have, we're going to go back to x to the sine of x. Is this from the positive side? Okay. So it's indeterminate because we have 0 to the 0. So we're going to do this one together, and log of x to the sine of x. Cool? E to the limit as x goes to 0 from the positive of sine of x, log of x. Now this one's not quite as obvious as making a fraction right away obvious. So we have to decide what should we put in the denominator. We have to make it a fraction. So what should we put in the denominator? Cosecant. Okay, sounds good. So e to the limit as x goes to 0 is log of x over cosecant. Sine in the numerator is the same as cosecant in the denominator, right? All right. The natural log goes towards negative infinity. Cosecant, we're a little rusty on, or at least I'm a little rusty on. Cosecant. Here's cosine. Cosecant as x close to 0, wouldn't it go to infinity? And so that is indeterminate, right? Negative infinity over infinity instead of an original L'Hopital form. So we can use L'Hopital. And this is equivalent to e to the limit as x goes to 0 of 1 over x over negative sine of x, negative cosecant of x cotangent. See? At that point, I'm not sure what to make of that. It was like infinity times infinity, so that's kind of gross, but at the very least, let's rewrite it so we can make our life a little better and call it, if I put those 1 over sine and 1 over tangent, then flipped it, isn't that the same as negative sine tangent over x, if I cleaned it up? Do you agree with that? Okay. Now, what do you see in the top then? Where does it go? Goes to 0. It's going to 0. The bottom's going to 0. So sadly, it is L'Hopital again. Limit as I know. X goes to 0. Negative sine of x, tangent of x is 0. The limit as x goes to 0 of x is 0. And so by L'Hopital again, e to the limit as x goes to 0. Good news is it only happens that time. Now will be golden. What's the numerator derivative? Negative sine of x, secant squared of x, minus cosine of x, tangent of x, okay? Over 1. As x goes to 0, what does sine secant squared approach? 0. And what does cosine tangent approach? Cosine's 1, but tangent is 0. So e to the 0 is 1. And that's a whole lot of work for just a simple little 1. But that is what it is. Alright? Okie dokie. So, that's the new stuff. Are you down? The good news is this is the last indeterminate lesson you'll have to do. So there's that. Questions on 108 and 109. I'll do them in whatever order you ask.
5.
On 108.5.
108.3.
108.7. 108.3.
109.20 and 25.
109.20 and 25.
109.23.
22B.
23.
23B. What, Eric?
108.19 and 22.
Okay. Here we go. This thing is making. This thing needs a little. Okay, here we go. 108.5 is, gotcha, I remember. All right, so here we go. By the way, I understand I didn't post the keys. I have them done. I just did them last night, so I will post them before 7th. The keys will be posted before 7th hour if you need to finish stuff up 7th hour. 1085. It says find a unit vector parallel and a unit vector normal or perpendicular to the tangent to y equals 3x squared minus 4 at 2, 8, 5. Oh, let me make sure I have that. Yes. Okay. So, the picture's not necessary, but it does help to explain the concept. You got this tangent line at 2, 8. Okay? Your goal is to find a little baby unit vector that's parallel to that. So, it doesn't actually have to be here. It just has to have the right horizontal and vertical parts to it. And you also want to find one perpendicular to it. So those are the two things you want. Now, first, get the direction by finding the tangent, or the tangent slope. So take the derivative, 6x, evaluate it at 2, and that's 12. But it's crucial that you start to get components to this. So 12 isn't good. 12 over 1, that's good. That tells you that the growth rate there is a vertical change of 12 and a horizontal change of 1, so that you can put this into a component form. You know, the basic direction is 1/12, or a horizontal movement of 1 for every vertical 12, right? Now we work on the unit vector. Unit means it needs to be shorter. Right now, how long is this vector? By Pythagorean theorem right now, it's root of 145. So to shorten it, we divide by a factor of root 145. So we still keep it in the same direction by still using those horizontal and vertical pieces, but we shorten it by dividing by the length of the vector. And if I did Pythagorean theorem, you'd see that's 1 long. You with me? That's parallel. Perpendicular then will be the same kind of directions, but changed a little. How do I get a perpendicular vector? Yeah, switch. And do I take both opposites or just one opposite? Just one opposite. And it doesn't matter which. You could write it with the negative on the first, and the person next to you could put the negative on the second. And it would just be the difference between this vector or this vector. But they're both perpendicular. Okay? All right. 1087. Is still a question, yes? Okay. Okay, so I've got cosine from negative pi over 2 to pi over 2. And the x-axis rotate around x equals 3. So first thing, check that you did the right x equals 3. Is x equals 3 a horizontal line or a vertical line? Here's x equals 3. If it's rotated about x equals 3, then we get a reflection like that. And so we get this bundt cake kind of shape. This kind of thing, yeah? So we definitely want to approach this right. Should we use these kind of slices? Or, yeah, we want to use X slices. And if I use that kind of slice, then what's my volume method I'm going to work with? Shells. So we're definitely using cylindrical shells. The idea, if you recall, is to unwrap it, and the circumference and the height need to be determined. The thickness is dx. So 2 pi out front. The hard part by far is the radius. The radius is here. 3 minus cosine or 3 minus x? It's 3 minus x. Okay, 3 minus x is the radius, the cosine comes in on the height side. The cosine is the height. And we talked about this earlier, but I'll remind you, you cannot use symmetry here. Because the volume of the inner part revolved is not equal to the volume of the outer part. You cannot do two zero partitions. Okay? All right. 1083. Is that still a question? Okay. 1083 is. Oh, yeah, gotcha. I'm with you. I failed to get this into my notes properly. If I were to ask you to sketch J hat, what does J hat look like? J hat is a vector that is 1 unit long going through. This is J hat right here. Okay. All vectors are just combinations of that 1 unit long vertical and that 1 unit long horizontal, which is I hat. Now, this then is exactly 1 unit. We're taking this vector, which is pointing at 90 degrees, and rotating it counterclockwise. Or not. This is obviously just Dunner's here. It's just gone. Now it's just gone. What the freaking heck? Whatever. I don't care. All right, so we're taking this vector and rotating it 150 degrees. Now, if it was at 90 and you rotated 150, where does that put it? At 240 degrees, right? Now, it's also 1 unit long still, which really makes it now like a unit circle problem, where the x is just the cosine. What's the cosine? Of 240. Negative 1/2. And the sine is the vertical. So there's your answer to 1083.
Yes.
Okay. 10920. Do you still need 10920?
Yes.
Okay. This one's a good one. I can point you in the right direction here. So vector, whatever the first one is 4, 3. And the second one is negative 2, 7. There is a quickie formula for angle between two vectors, but it's not, unless you're a physics person, I guess, it's not really worth memorizing to me. You can do it without it. You guys will learn it. It involves the dots. Have you guys done dot products yet? Yeah. Okay, so it involves that. All right. Now, rather than think of them in relation to each other, think of them in relation to the x-axis. We want this angle, yeah? Do you agree? Think of, first of all, could you find me angle alpha? Yeah. Could you find me angle beta? So beta then is just beta minus alpha. The angle between would be the whole angle to the long one minus the whole angle to the short one, yeah? So now let's focus on those details. Beta. How would you find this angle beta? You probably want to go in reference to pi and work this triangle, right? So how would you find that related angle by trig? Inverse tangent of 7/2. That would find this angle, right? So then beta is, am I not explaining this well? Pi minus inverse tangent of 7/2. That would give you angle beta. Now you could take away angle alpha. How would you find angle alpha? Inverse tangent of 3/4. Now mention the angle in between.
Yeah.
Okay. 109.25.
Yes.
Okay.
Like just B and C.
Just B and C. Okay.
Okay.
I'll be here 7th hour. I'll continue as long as you want, whatever, as long as you're staying on things. Okay, I wasn't sure what they were talking about. Is that your confusion too? Because I wasn't sure what to do. So, I guess this is what I interpreted. When x is large means what's the limit of f of x over x, which means what does this equal? X squared plus x minus 2 over x all over x. It would be eventually. Okay, I think you'll agree that, yeah, this would approach, for large x's, it would just approach 1. I guess, that's what I...
That's what I thought when it said large.
Yeah, I don't know why they had to get so funky, but yeah, that's what I took it.
C.
C was weird.
And then C, yeah, the limit as x goes to infinity of x, f of x, is the limit as x goes to infinity of x squared plus x minus 2 over x. So I feel like it should be x squared plus x minus 2, yeah. Problem is that's not a monomial. So I feel like what he's getting at, I don't think it's a great question, but what I think he's getting at, in terms of end behavior, as you get infinitely large, this would mean less and less, and it would start to pretty much approach it. I think that's what he means, is the monomial expression. Is that what they have for an answer? Yeah. Okay. I guess that's what he wanted. Right? To me, it was a weird question. Okay.
Number 3, the test. How do I like your calculator work around?
Which one? Oh, 23?
For 109.
109, 23?
Or just 3.
Just,
So like when you have the x in the calculator for the distance.
yes. So some calculators will give you an error message. Did you, like,
Yeah, I got
or
the
it'll
error
say, yeah. So,
It was like a really, really big number.
yeah, really big number doesn't bother me, but if this is problematic because of the root in the denominator problem, then instead tweak it a little and talk about just shy of 0.
I did that too, and it still gave me an error.
Oh, did it?
Yeah.
Okay. Well, ignore that message. It gave you an error, it said questionable accuracy.
It didn't say error, it probably just said question accuracy.
Yeah.
But the answer was way off.
Oh, really?
Like, it was like 5.401 times 10 to the 24.
Oh, yeah, it's definitely not infinitely long. Is it? I don't think it's infinitely long. Here, let's. So that's calculated by calculation. Yes, sir? That is a part of it. Or quick.
I wanted to sit in the middle. No, I said, always sit in the middle. Here. Destiny, oh my god. So it sounded like it. Mule! Mule! Sarah. Mule! Mule! Oh my gosh, stop! Oh my gosh. Bye-bye, Sarah. Bye-bye, Sarah. When in doubt, blame it on Sarah.
So maybe your derivative, yeah. Is this 3 you said?
Guys, now we have to move.
So it was x, the original function was x to the 2/3. So why find,
Yeah. Oh, 1/3.
No, don't.
so it should be something like
She takes it with her.
1 plus
No, run.
maybe 4/9
Slam.
x to the negative 2/3 if you square it,
Yeah.
right? Hi. Thank you for telling me.